All right, kids, so this is the same problem we use for confidence intervals. I want to do a hypothesis test example. So my first thing I'm going to do is write my hypotheses. So there's always two competing hypotheses. My first one is the null hypothesis. So I would like to write this using symbols and in words. So my null hypothesis says that the population proportion P is equal to 0.5, or the population proportion of voters who prefer candidate A is 0.5. The alternate hypothesis, keeping it simple, I'll kind of take a clue from what my sample suggested, is that the population proportion P is actually greater than 0.5. The population proportion of voters who prefer candidate A is greater than 0.5. So you should be getting the habit of writing your hypotheses using symbols, but also writing it in context using words. So the conditions, I'm not going to check all the conditions because I checked the same conditions on the confidence interval video. The only condition that changes is the big enough condition, because we're predicting what we would expect to see based on our population proportion. So I'm not counting the number of successes in the sample, but I'm saying given that the population proportion is 0.5, how many successes and failures would I expect to see? So in a sample of 250 people, I would expect to see about 125 people prefer candidate A and 125 people to not prefer candidate A. Both of those are greater than 10, so the sample is large enough. And large enough for what? Well, large enough to use a normal model. So again, here's the model that I'm going to use in this situation, and the model is based on my null hypothesis. Sometimes that is written as P sub 0, the null proportion. And what I'm looking for is the probability that given the mean is 0.5, or given this model, how likely is it that I end up out here in the tail of my distribution? And so using a normal CDF with a lower bound of 0.7, an upper bound of infinity, a mean of 0.5, and a standard deviation, this is a standard deviation of 0.316, that's essentially 0. So my p-value is essentially 0. So my conclusion, since my p-value is small, I'm going to reject the null hypothesis. I reject HO with a p-value of essentially 0 being less than any reasonable alpha level. One of the things that we'll need to practice doing is making this statement that connects our p-value to the alpha level. I have evidence to suggest that the population proportion of people preferring candidate A is more than 0.5. That's my conclusion. Now, one thing you'll have to do from time to time, you'll have to explain the meaning of a p-value, and a p-value is a conditional probability. Given the null hypothesis is true, the p-value is the probability of seeing a sample p-hat as large or larger than the one we saw. And so in symbols, I would write it like this. The probability that p is greater than or equal to 0.7 given p is actually equal to 0.5. So the p-value is a conditional probability. So hypothesis test and confidence intervals are just two sides of the same coin. I hope this video has been helpful.